Alright, so today we are going to learn about domain and range of functions based on their formulas. So if we're given the explicit formula of f of x and g of x, and now we're asked to find the domain and range of these functions based on the given formula. So, oh yeah, if you're following along in the Stewart calculus book, these two problems are actually example number 6 in the book, if you're just following along through there. So let's start with number 1, f of x. So f of x is equal to the square root of x plus 2. Okay, so because the square root of a negative number is not defined as a real number, the domain of f of x consists of all the values of x such that x plus 2 is greater than or equal to 0. Alright, so under here, this is very important. Sorry if you hear the lawnmower man outside, he's mowing the lawn. This part under the radical cannot be less than 0. It can equal 0 because the square root of 0 is 0. However, it cannot be less than that. We don't know how to find the square root of -1 or something like that. So what do you do to find the domain? You set this expression equal to 0, in this case greater than or equal to 0, and then you solve for x. So in this case, x is greater than or equal to -2. Alright, so how do we write that in interval notation? Well, you have bracket from -2 all the way to infinity. Just like that. Square bracket here because you can have -2 as an answer for x, and then infinity and curved bracket. Alright, so that's the answer to -1, the domain. And now the range. The range for this problem is the range. If you visualize it on a graph, right, this is the graph of, oh, that's a really bad graph. This is the graph of square root x, and then x plus 2, the new graph, is x greater than or equal to -2. So here's -2, and here's the graph of f of x, or square root x, -2. So the range looks like it goes from 0 all the way to infinity. So the range is 0, infinity, because it just keeps on going in the diagonal upward direction from 0 and then from -2 xy's. So that's question 1. Now question 2, we're going to do quickly. G of x is equal to 1 over x squared minus x. So 2, g of x is equal to 1 over x squared minus x. Alright, so this looks complicated, but it's not really. I'm going to rewrite it. I'm gonna factor out an x in the denominator. So now it becomes 1 over x times x minus 1, right? Because when you plug x back in, you get this. So we factor an x out, and you get this. Now, as we know, you cannot divide by 0. Ever. Illogical, impossible. You can't. So you have to exclude all the points in your denominator that would make the denominator equal to 0. You have to exclude them from the domain. So what values, when you plug in x, make the denominator 0? Well, here would work with 0, right? Because 0 times any quantity is 0, and that makes the whole denominator 0. So 0 we have to exclude from the domain. Here, if we plug 1 in, we get 1 minus 1, and that's 0. And then you get 0 in the domain again, and you can't do that. So 1 is another point we have to exclude from the domain of this function. So how do we write this in interval notation? We write it like this. I will use green. The domain of g of x, wow, that's really bad, whatever, is interval notation. The lowest we go is to infinity, and oops, and we go from infinity all the way up to 0, so it can't be 0, right? So we're not doing the inclusive brackets. Union symbol, that means basically and then from 0 to 1, all those points between 0 and 1 we can have in the domain as x. Union, and then from 1 to infinity. I don't know if you can, if that's off the, yeah. So from all the points in between here, plus all the points in between here, plus all the points in between here. If you plug them in, you get a good function, a good output, a unique output, and you don't get 0 in the denominator. That's basically what we want with the domain. The range of this is a little... you would have to... I would use a graphing calculator to graph this first. I don't know how I'm doing on time with this video, actually. Let me graph this on my graphing calculator. And if you have a graphing calculator, use it, please. I highly suggest you get a graphing calculator because they are just awesome sauce. Okay. So if you graph this, oh, and when you do graph, and you find out that your domain excludes points on a graph, you have to realize that the graph will not cross those points at x. So we said 1 is excluded, 0 is excluded. Let me do it in a different color. 1 is excluded from our domain, and 0 is excluded from our domain. So looking from my graphing calculator, if we plug in points, you're going to get a graph like this. And then so it's really hard to tell the range of this from just looking from the graph, and I don't want to show you how to get the range right now for this because it'll make my video go really long, but it looks like the range is somewhere from 0 to let me check my graphic calculator. Somewhere from 0 to -4 maybe is probably the range, but we'll do that in a later video. For now, knowing the domain is really all you need to do, and actually that's what the problem asks. That's all the problem asks in the example. So we've accomplished what we needed to accomplish. So that's domain. That's domain based on formulas of 2 equations that I have here. All right, stay tuned. See you in the next video.